With any luck, at the end of the last video, you did pick up on something I was trying to hint at, which is the idea that the second part to each problem, in number 1, had a lot to do with the first part. It was actually just a small rearrangement of things. For instance, in question number 1, it wasn't a coincidence that you heard me say the phrase log base 2 of 4 twice. I said it over here on the right hand side when I said log base 2 of 4 times 3, or 3 times log base 2 of 4. But when I read the left hand side, I said log base 2 of 4 cubed, which means the same log base 2 of 4 appeared in both of those statements. Now, what do you notice was the only thing left over that I didn't just highlight there was that 3. And it is not actually a coincidence that that 3 is the exact number that was in the little blank on the right hand side. Now notice that for a second and see if you can make the same connection in letter B. Remember the part that I said twice? You can go back and rewatch the video if you need to hear me say it again. When I read the right hand side, I said 2 times log base 5 of 5. When I said the left hand side, I said log base 5 of 5 squared. Log base 5 of 5 appears in both of those statements. And think about what's left. The only thing I didn't highlight here was this little power of 2, which, not coincidentally, is the same number that was in the blank on the right hand side. So once again, I'm seeing a completely consistent pattern, and it seems as though that pattern has worked for 2 problems in a row. Let's see if that pattern holds up in question letter C. Notice the part that seems to be the same. Log base 3 of 9 on the right, and sure enough on the left there's another log base 3 of 9. Totally not a coincidence. And what's left over? A little 2 as an exponent, which matches the 2 that was in that blank. One more example just to see if that makes sense. Log base 2 of 8 appears on the right. Log base 2 of 8 definitely appears on the left as well. What's the only thing I didn't highlight there on the left? It's a little power of 3, which matches the 3 from the blank on the right. So it seems as though we have a property here, a relationship that is not just a coincidence. What you actually are looking at here is something called the power property of logs. The power property refers to the fact that in the left-hand side of each of these problems, that number that I highlighted yellow was a power. On the right-hand side, that number no longer looks like a power. It looks like a number in front multiplying. And that's because the power property says that any exponent on the right-hand side of a log problem can be brought down to the left-hand side to become a multiplication. So it's actually like this movable piece that can move from one location to the other. As long as you have a log expression, you can do that movable piece. So the official pattern, if you ever see it in like a textbook or maybe in your math analysis class next year, the official pattern looks like this. That if you have a log of any base, we'll just call that B for base, any base, that has any letter x to the power of any power p. I'll just write it like that with those variables. Then technically that p, that power, is movable. And you can move the p down in the front and leave the rest of the log completely untouched. So notice the log base b and the x can stay exactly untouched, and the p can just move down. So the p is like this movable piece. The power is this movable piece that can move down if you want to, or up if you want to, depending on whatever you want to accomplish. If you're not sure what that means yet, stay tuned for the 3rd video, because the 3rd video will show you what exactly you can do with this property.